Okay, so today I have a short video for you guys on how to use the Pythagorean theorem to find the missing side in a right triangle. Hopefully, this is review for you. My goal is just to kind of get you guys refreshed using the Pythagorean theorem so we can actually start using it the way we need to be able to use it. So if you've never heard of it before, the Pythagorean theorem basically says I can find a missing side in a right triangle if I know two of the three sides. So I'm going to give you two of these measurements, and we're going to set up an equation to solve for the third one. Overall, a squared plus b squared plus c squared is going to be our formula that we use, where a and b are what are called the legs of the right triangle. They are the two sides that come together at the right angle. All right, the third side is the one across from the right angle called the hypotenuse. Now, if you notice, the legs A and B, they're pretty interchangeable. That isn't really, they're not that special. The one that is special, the one that we have to make sure that we can differentiate from the other two is the hypotenuse. We have to be able to pick out the hypotenuse in the triangle 100% of the time. So what this is going to look like, I'm going to give you two sides. You're going to find the third. I'll help you guys with them. Your assignment's going to be to do it on your own. So when I set this up, I can use 9 or 12 kind of interchangeably, but 9 squared plus 12 squared is equal to x squared. Now these are being squared, not multiplied by 2. So I need to make sure that I'm multiplying these numbers by themselves. So 9 squared is going to result in 81. 12 squared is 144. Now I'm going to go back and add those together. 81 and 144 is 225. Now, that's not our answer. That's our answer after it's been squared. So we've got to back that up a step. How do you undo a square of a number? Well, if you don't know, you've got a calculator that can do square roots for you. Either on your phone, or if you've got an honest to goodness calculator, you want to take the square root of 225. Now, most of your calculators, you're going to actually have to find the square root button and then hit that square root button and then type in 225. Some of the older calculators, if you have one laying around home, you probably have to put the number in first and then hit the square root button. But the square root of 225 is 15. Use a little bit of common sense on these. If you get to 225 and you stop, that doesn't track with your other numbers that you've got here. There's no way this side is 9, this side's 12, and then this one's going to be 225. That doesn't make sense. Okay, similarly on this next one, I've got my A and B. My hypotenuse is what's missing, so the setup's going to look exactly the same. I've got my A squared plus B squared equals C squared. 3 squared is 9, 4 squared is 16. Again, just multiplying those numbers by themselves. Add them together is 25. Square root of 25, again, don't stop until you've hit that square root button. Square root of 25 is 5. Hypotenuse of that triangle was 5. Now, you're not always going to be missing the hypotenuse. Let's suppose I'm missing one of the legs. Okay, the units don't matter. It can be feet, inches, miles. It doesn't matter. The arithmetic's what I'm concerned about. So when I set this one up, A, B, I know the hypotenuse. So the setup's going to look a little bit different, whereas the x squared isn't over on the right-hand side by itself. Okay, x squared, 6 squared, 8 squared. Again, square your numbers. 6 squared is 36. 8 squared is 64. When I subtract my 36, x squared is 28. Now this one, you're not going to get a whole number answer. Once you take the square root of a number that's not a perfect square, right? Again, type in square root 28, you're going to get this big, long, nasty decimal. It's going to start out 5.29, on and on and on and on. We're going to set a standard right now to round all of these to the nearest tenth. If it doesn't work out as a perfect whole number, give me rounded to the nearest tenth. So we're going to put the answer down to this one as 5.3.